Welcome to third semester mechanical engineering students. In this semester, you are going to be introduced with a very interesting subject of MCAD. MCAD stands for Mechanical Computer Aided Drafting. This is basically a practical oriented subject. After learning this subject, the student will be able to draw, edit, and modify the two-dimensional drawings. He will also be able to create isometric views and convert these isometric views into orthographic views. He will also be able to create simple machine parts models and do the assembly modeling. Now, to begin with, you should know what is MCAD. Since you are going to study this MCAD, you are supposed to know some fundamentals of MCAD. MCAD is basically a computer aided design software. So it is a CAD software. So what you are going to do with these CAD softwares is you can create the 2D drawing views which can be easily generated in the drafting environment after creating the solid models and assemblies. So you can generate the orthographic views. In the previous year, you have created the orthographic views. Here in solid modeling softwares or any other CAD software, you can generate the orthographic views with the solid models and assemblies. Then using the CAD softwares, you can also have the orthographic views, isometric views, sectional views, and detail views with bill of materials. Then what is the necessity of MCAD? Why you should study MCAD? As we are all aware that manual drawing is obsolete in the industry. Nobody uses manual drawings these days. Hence, computers are the effective replacement in the engineer's life. And all the CAD softwares will make it easy to create and modify the drawings, and ultimately it saves the time. The CAD softwares are also helpful in assembly and manufacturing drawings. You can also capture the design intent of the manufacturing model. So the CAD software will capture the design intent of the manufacturing model easily. There are various CAD softwares which you can use. Out of those, Solid Edge is one such software. Then there is Pro Engineer. Then there is a SolidWorks. Then there is CATIA. Then also there is AutoCAD software. We are going to introduce you in this course the Solid Edge software. So using Solid Edge software, you can go for parametric modeling. All the CAD softwares are parametric modeling softwares. So you should understand the term what is parametric. Parametric comes from the word parameters. Parameters means to draw any solid or any entity, you have to input the parameters. For example, to draw the cylinder, diameter of the cylinder and height of the cylinder are the parameters. Then to draw the cuboid, length, width and thickness of the cuboid are the parameters. So what we are basically doing in parametric modeling is the geometry of the model is controlled by its parameters like dimensions and relations. As I have said, the parameters of the cuboid are length, width and height. The rectangular block is driven by these parameters. We can also change the value of these parameters anytime during modeling process, and the model is updated automatically. At the same time, we can maintain the relationship between the parameters, like length is equal to twice the width. That means you can use the equations in the parametric modeling. It helps you to speed up your design process, because tomorrow if your design changes, your product design changes, you need not have to do it from the scratch. Just you have used the equations, just input the parameters in those equations, the model will be automatically updated. So these things will be studied in this subject. Then parametric modeling techniques. We will take one example. There are two diagrams in the screen shown to you. In the first diagram, a rectangular block is created with the help of length equal to 100 mm, width is equal to 80 mm, then thickness is equal to 20 mm. This is the first diagram. It is created by applying the relations to the parameters. What are parameters? The length is the parameter, width is the parameter, thickness is the parameter. All these parameters are given some values. In the second diagram, you can see the model is created after creating the parameters. See, in the second diagram, we are modifying the parameters like length equal to 50 mm, width equal to 40 mm, thickness 20. You can change thickness also. So by changing the parameters, the model will be updated automatically. In the first case, you can see the size of the model is big. In the second case, it is small. So what we have done is we have applied the relations before and after. So the model is automatically updated without actually deleting this model. In manual drawing, what you were doing, you were creating this model. Then if any change happens, you have to erase this again and then construct this model. Whereas in all the CAD softwares, including the solid edge, which we are going to teach you, the parametric modeling capability will help you to speed up your work. Any change in the design will be automatically updated. So parametric modeling basically it involves the use of relationships to the parameters. All you have to do is identify the parameters. Then parametric modeling techniques. This is second method of parametric modeling. Here you are specifying the equations. Like you can see length equal to 2 into width, thickness equal to 1/3 of width. These relationships or equations are applied in most of the mechanical design engineering process. For example, if you are designing the coupling, if you change the shaft diameter, then hub diameter automatically changes. All other dimensions related to the coupling will change. if you simply change the shaft diameter. Okay. So the entire idea of parametric modeling is to develop the model by modifying the dimensions. So the dimensions will control the geometry of the model. This is known as parametric modeling technique. This will be dealt in detail throughout the course when we are going to introduce you to the solid edge software. Now, most important thing is you should understand the software interface. Software interface is most important. That is, since we are going to use solid edge, let us talk about solid edge software interface. So what it does is, solid edge is a window application. So the commands behave like typical Windows commands. But still, solid edge interface is very easier to learn new commands on your own. And even the concepts, regardless of your experience with Windows. So even though the user is not well versed with the Windows, still he will be able to make use of the solid edge and use it very effectively. Now let us see the solid edge interface. The solid edge interface consists of pull down menus, toolbars, tool tips, status bar, edge bar, graphics windows. Let us see one by one. Let us see what is pull down menu. You can see the pull down menu here. This is what we call it as a pull down menu. So each time you click on the menu bar, a menu is pulled down like this. If you click on modify, a menu is pulled down there. If you click on tools, a menu is pulled down here. So this is known as a pull down menu. It is almost similar to the menu which you see when you go to the restaurant. Once you go to the restaurant, a menu will be given to you. It is similar to that. So pull down menu, basically there are menus, commands which are grouped and placed for the convenience of the users. So all these things are meant for the convenience of the users. When you open the solid edge software, you can see this blue color ribbon, blue color strip. It is a title bar. It is a title bar. Next is these things you can see: file, edit, view, these things. It is called menu bar. Then for each menu, you have a pulled down menu or a pull down menu like this. Then you have the graphics window. Here it is edge bar. All these things are part of the solid edge software interface. So this is regarding the pull down menu. Then there are toolbars. One such toolbar is shown here. It is a toolbar known as main program toolbar. It is almost available in all the programs. This is for new application. This is for opening the existing application. This is for saving the application. This is for undo. Like this, the toolbar will help you immensely to do your work. So basically the toolbars contain the tool icons. These are all icons. These are all icons for invoking a particular command. So if you want to invoke a particular command, you have to click these icons. So the toolbars are most useful interface in the solid edge software, like any other software. So similarly, another most important interface is tool tips, particularly for the beginners. If you are using the Solid Edge software for the first time, still then you need not be worried, because it has got a tool tips. The tool tips, it is shown here in this diagram. What it shows is, it gives you the information on the command name and its purpose. So if you are a beginner, you are not knowing what this particular command is doing, you take the mouse pointer near it, it will show and guide you like this. This command is protrusion command. It is used for creating the feature which protrudes from the existing part or sketch. So the tool tips are guide. It is almost a guide for you. You need not refer any other books or other things to know the commands. Just you take the pointer near the icon, it will help you what that particular command is doing. So this is the most useful interface here. That's why I said, even if you are not familiar with Windows, still you can do your work, create your drawings, create your solid models, assemblies. All these things can be done even though you are not familiar with Windows, because the Solid Edge interface is very, very, very user friendly. Next interface is status bar. This shows the informations and also the messages at the top of the window. It will also explain the actions of the tool, or it acts like a command prompt. See, it is the status shows, suppose if you click on any part creation icon, then immediately this bar is prompted up on your screen. It shows on which plane you want to create the feature. There will be n number of options under this. So this is status bar. It is helping you to continue your work once a particular command is created. Next is edge bar. Without edge bar, you cannot create the, or you cannot modify the solid models. You cannot create the assemblies. Edge bar is almost necessary part in the Solid Edge interface. You have to keep this edge bar at the left hand side of the screen. What this edge bar does is, it is basically a model tree, or it is just like a menu tree. What it shows is, it shows the history of the model. It is just like child and parent relationships. Suppose I have created one feature here. This feature will be displayed in my display window. Once that feature is created, here that feature is populated in the edge bar. So for this first feature, it is called a base feature. Then these three planes, horizontal plane, vertical plane, and profile plane, these are the parents for this feature. Then there is one more feature here, hole. For this feature, these are the parents. So it is in a way parent and child relationships. This is shown or displayed in the edge bar. Edge bar shows the most important feature of a history tree or a model tree. So using this model tree, you can change your model at any particular feature you want. These are all features. Suppose you want to change your design of the model at this level, that is protrusion 3. You just click here, make the modifications, then save it. Every model will be updated automatically. This feature is known as feature-based modeling. Whereas if you are doing it manually, if you want to change your design at the feature level, it is impossible. You have to erase the entire model, then you have to update it. All these solid modeling softwares, including Solid Edge, they are giving this option of a feature-based modeling. That is, you have to change your model by going to the feature level. Only that feature will be changed and the entire model will be updated automatically. There is no need to delete the entire model. Okay. Suppose you have created a simple hole here. You have created a simple hole and tomorrow you want to change that to threaded hole. Just click here on the hole option, then take the threaded hole. The hole will be modified as threaded hole and the model will be remaining as it is. This is known as feature-based modeling. To do all these things, edge bar is a must. Without edge bar, you cannot do these things. So it helps us to manage and complete the task of design. Whenever there is a design changes or modification, you have to do the modifications at the feature level. So edge bar is the most essential component of solid edge interface. Then graphics window. This is the graphics, the model. This is the model. Graphics window is the space or region where model is displayed. You can see the model is constructed here in the display pane. Then this is the edge bar, which I have told in the previous slide. So by change, suppose you want to change these holes, make it large. You can click here, hole, change the hole dimensions, you will get a large size holes. Even if you click the other type of holes like a counter bore hole or a countersink hole or even threaded hole, that also will be updated here. The model will be same, only these features will be changed. This is called as feature-based modeling. I repeat this because feature-based modeling is the most important feature in the design process. If you understand feature-based modeling and parametric modeling, your design will be most flexible. Tomorrow, if your design changes, you can still make adjustments to the designs without deleting these models again and again. So in graphics window, you can see the model here and the features are shown here in the edge bar. Now, before I conclude, I would like to have some MCQs, that is multiple choice questions. Which software is not used for the computer aided drafting? Options are Solid Edge software, CATIA, Pro Engineer, and MS Office. So the first three softwares, Solid Edge, CATIA, and Pro Engineer, these are used for computer aided drafting and design purpose. The question is, which is not used? So the obviously answer is MS Office. MS Office is used only for creating the documents, that is Word document, spreadsheet document, presentations, PPTs, all these things. So the answer for this particular question is MS Office. It is not used for computer aided drafting, MS Office. Next, CAD, that is computer aided design. It is the relationship between science and engineering, manufacturing and marketing, design and manufacturing, design and marketing. So CAD is the relationship between science and engineering. No. Computer aided design, it helps you to draw and design. So design should be there in your answer. Manufacturing and marketing, no, there is no design here. Design and manufacturing, design and marketing. So whatever information or details that are provided in the CAD database, computer aided design database, the same database is shared to the CAM database. CAM stands for computer aided manufacturing. So whatever design you have carried out, those databases is transferred to manufacturing department with minimum data loss. Hence, CAD is the relationship between design and manufacturing. There is no separate CAM database. The design database is transferred to CAM, that is computer aided manufacturing database. So we can say CAD is the relationship between option C, design and manufacturing. In the first option, there is no design. Second option, again, there is no design. Third option, there is design, but marketing is here. So this database goes to manufacturing department. So the answer is C. Next question. In parametric modeling, geometry of the model is driven by, your options are dimensions, tolerances, relationships, both A and C, that is dimensions and relationships. So I have explained parametric modeling in detail. So parametric modeling, dimensions will drive the geometry of the model, and also relationships, that is how one parameter is related to the other parameter, that is also important. Hence the correct answer is dimensions and relationship. In parametric modeling, you have to tell what are the dimensions, and also you have to tell what are the relationships. Hence the correct answer is both A and C. We are not interested in tolerances in this stage, at this stage. So the correct answer is A and C. Next question for you. The features of solid modeling softwares are, first one, parametric in nature. Second one, feature-based modeling. Then bidirectional associativeness. Then all of this. So the four options are there. Let us understand one by one. What is parametric in nature? Parametric in nature, we have understood what is the parametric modeling. We have understood this. That is, the parameters will drive the design of the model. Feature-based modeling, we are able to change the design of the model at the feature level. Then bidirectional associativeness, that means there will be many departments for the CAD softwares. If you do changes in one department, those results of the changes will be reflected in other department. This is known as bidirectional associativeness. That is, if you change your design in the solid modeling of a part stage, then that change will be reflected in the drawing mode also. That means you can change the design at any stage, and that result will be reflected in the other department also. So to summarize, what are these three? Parametric in nature, feature-based modeling, bidirectional associativeness, all these things. Parametric is relationship between two entities. Parametric modeling is relationship between two entities. When I say entity, it can be relationship between length and width, or it can be relationship between diameter and height, like that. Whereas bidirectional associativeness means it is the relationship between two departments. So if you make changes in one department, those changes will be altered and effectively incorporated in the other department also. Suppose if you change in the assembly modeling, then you can expect the changes in the part model also. So the answer is all of these. Nowadays, all the solid modeling softwares, they provide all these capabilities. Hence, the answer is all of these. Solid modeling softwares are capable of parametric in nature, feature-based modeling, and bidirectional associativeness. Next, MCQ. Which of the following are essential features of the solid edge software? Pull down menu, edge bar, ribbon bar, all of this. So you need pull down menu to know the bunch of commands. You need edge bar to know its menu tree or history of the model. Then you need the ribbon bar where the dimensions of the entity is displayed. All of this. So you need all pull down menu, edge bar and ribbon bar. All these things are essential solid edge interface features. So after knowing these things, we can start constructing the models in the next sessions. Okay, thank you.